Hello everyone, and welcome back to the Fluctus Channel. Modern naval stealth is built around reducing the signals a ship gives away. Radar energy is deflected by angled surfaces, infrared signatures are controlled through exhaust design, and loud machinery is isolated to make detection harder for enemy sensors. The idea is not to make a warship invisible, but to make it difficult to find, classify, and target in the seconds that matter. The U.S. Navy's Zumwalt-class destroyer uses a sharp tumble-home hull, enclosed equipment, and a low-profile superstructure to reduce its radar return. Littoral combat ships, such as USS Freedom, were built for speed and flexible missions close to shore, where small crews, aviation facilities, and modular packages allow fast response. Sweden pushed the idea even further with the Visby-class corvette, a compact Baltic warship shaped around stealth, speed, and shallow water fighting. In narrow seas crowded with islands, ferries, submarines, drones, and missiles, a ship that can patrol has a major advantage. It can appear late on an enemy screen, launch sensors or weapons, then disappear again among coastlines and weather. That is the setting for Sweden's modern corvette fleet, built for a sea where every mile is watched. Sweden's Visby-class corvette is one of the most distinctive warships in Europe. Designed and built for the Swedish Navy, it was created for the Baltic environment, where shallow water, rocky archipelagos, commercial traffic, and short distances demand a small but highly capable combatant. The ship is roughly 72 meters long, displaces around 640 tons, and can reach more than 35 knots, giving it the speed to move between islands, coastal choke points, and open patrol areas with little warning. Its most recognizable feature is the hull form. Smooth flat panels, hidden equipment, and a carbon fiber composite structure reduce radar reflection. Instead of the cluttered decks seen on older ships, weapons and fittings are concealed when not in use. Even the 57mm Bofors gun is mounted in a stealth-shaped housing, allowing the corvette to keep a cleaner profile until it is time to engage. Life on board is tight, practical, and focused on readiness. Passageways are narrow, compartments are compact, and every room has a purpose. The bridge gives the crew a clear command picture, while the operations room gathers radar, sonar, navigation, and communications data into one fighting center. Sailors work in shifts, keeping watch, monitoring contacts, maintaining systems, preparing meals, and sleeping in close quarters between operations throughout long, tense watch rotations at sea. On a ship this size, personal space is limited, so discipline and routine matter as much as technology. The Visby-class was built as a multitasking platform. It can support surface warfare, mine countermeasures, anti-submarine work, patrol missions, and air defense coordination. Its water jet propulsion helps it move quickly and maneuver in coastal waters. Sonar systems and underwater sensors give it value in submarine hunting, while missiles and guns allow it to threaten larger vessels if needed. In the Baltic, where Russian naval activity and NATO patrols often share nearby waters, that flexibility is especially important. During NATO exercise Trident Juncture, 2018 inches Norway, Swedish Visby-class corvettes operated with allied and partnerships during one of NATO's largest post-Cold War exercises. The wider exercise involved about 50,000 personnel, 65 vessels, 250 aircraft, and thousands of vehicles, making Sweden's stealth corvettes part of a broad, multinational test of maritime cooperation. These ships did not need to dominate by size. Their value came from blending into complex waters while sharing information with a larger force. Corvette crews also train for damage control and medical emergencies, because even a modern ship can be helpless if fire, flooding, or injury spreads faster than the crew can react. Sailors practice firefighting, patient handling, compartment isolation, and emergency reporting. Helicopter operations add another layer, with the ship coordinating aircraft approaches, deck safety, and sea state awareness. Swedish corvettes have also been used in international security missions, including escort work that helped protect vulnerable shipping from piracy threats. The result is a small warship with a large mission set. It patrols, listens, hunts, escorts, rescues, and fights, while depending on stealth to survive in waters where bigger ships may be easier to detect. The U.S. Navy's closest comparison to a small, fast, mission-flexible corvette is the Littoral Combat Ship. The LCS was designed for operations close to shore, where mines, diesel submarines, small boats, and coastal missiles can threaten larger warships. Instead of building one traditional frigate, the Navy developed two different designs: the Freedom variant, with a steel monohull and aluminum superstructure, and the Independence variant, with an aluminum trimaran hull. Both were intended to combine speed, shallow draft, aviation support, and mission modules. The name explains the mission. Littoral means the coastal region where land and sea meet. These areas are busy, difficult, and dangerous. Fishing boats, merchant traffic, reefs, harbors, islands, and short-range threats can all mix together. A ship operating there needs sensors, helicopters, small boats, weapons, and a crew trained to react quickly. The LCS also proved that small surface combatants can operate far from home. USS Charleston made history by operating in distant waters and supporting forward naval presence, showing that the class was not limited to short coastal demonstrations. Aboard these ships, the watch team keeps constant attention on navigation, contacts, engineering status, and mission equipment. The crew is smaller than on traditional surface combatants, so sailors often carry multiple responsibilities. Aviation is one of the ship's most important strengths. On USS Fort Worth, the MQ-8 Fire Scout unmanned helicopter conducted flight operations from a moving deck. This kind of system extends the ship's eyes beyond the horizon. Instead of sending the ship directly toward danger, the crew can launch an unmanned aircraft to search, identify contacts, and relay information back. The LCS has also grown more lethal through missile systems. USS Gabrielle Giffords launched the Naval Strike Missile, giving the class an over-the-horizon surface attack weapon able to threaten enemy ships at long range. USS Jackson completed a missile test using CRAM, a defensive system that combines radar, sensors, and rolling airframe missiles to protect against incoming threats. USS Montgomery completed Combat Systems ship qualification trials, using its gun and weapon systems to prove combat readiness. The 57mm gun gives the LCS a rapid-fire weapon for surface targets, patrol craft, and close threats. Small boats can be launched for boarding or security tasks. Helicopters can track submarines, move supplies, or conduct search and rescue. Mission packages can tailor the ship for mine countermeasures, surface warfare, or anti-submarine roles. Although the program has faced criticism and redesigns over cost, survivability, and module delays. Still, the concept remains important. Like Sweden's corvette, the LCS is built around speed, sensors, and adaptability rather than battleship size. It is meant to work in crowded waters, support partners, and bring aviation and missiles into areas where a larger destroyer might not always be the best fit. Together, the Visby and LCS show how modern navies are trying to solve the same problem in different ways. Build ships that can patrol complex waters, respond fast, and survive through awareness, mobility, and smart design during deployments and alliance patrols abroad. Stealth ships and coastal combatants are only one part of undersea warfare. The most dangerous emergency at sea may happen below the surface when a submarine is disabled and sailors are trapped with limited air, power, and time. For that crisis, NATO and the US Navy rely on specialized rescue systems built to locate a distressed submarine, reach its escape hatch, seal against it, and bring survivors back under controlled pressure. The NATO Submarine Rescue System is a cooperative project involving France, Norway, and the United Kingdom. Its rescue vehicle, often called Nemo, can dive to about 600 meters and dock with a submarine hatch. The full system includes an intervention system, a submarine rescue vehicle, and a transfer under pressure complex, allowing rescued sailors to move from the vehicle into medical and decompression facilities without pressure changes. The engineering is built around precision. Rescue teams must locate the submarine and assess conditions. Sonar, remotely operated vehicles, and underwater cameras can help confirm the boat's position, angle, and hatch condition. Then the rescue vehicle is launched from a support ship and guided down through dark water. Pilots use thrusters, sensors, and lights to approach the submarine without striking it. The hardest moment is mating with the hatch. The rescue chamber must align over the submarine's escape trunk, settle into position, and form a watertight seal. Once pressure is equalized and the connection is safe, submariners can move into the chamber. Some systems carry a small group each trip, so rescue may require dives, medical checks, and coordination between the surface team and trapped crew. The U.S. Navy's Undersea Rescue Command trains for similar emergencies with submarine rescue chambers and deep submergence rescue systems. During Chilmar 3, U.S. and Chilean forces practice submarine rescue procedures, including chamber operations, diver support, deck handling, and medical transfer. These drills teach crews how to move from alarm to action, mobilize equipment, rig the chamber, launch safely, make contact, transfer survivors, and recover the system. The process is slow because it cannot be careless. A disabled submarine may be resting at an angle, surrounded by debris, or affected by currents. Survivors may be injured, cold, dehydrated, or under pressure. Medical teams prepare to receive them, while engineers monitor cables, lifting gear, seals, oxygen, and communication lines. Every stage has to work because there may be no second chance. This is where the story of modern naval technology comes together. Sweden's Visby-class uses stealth to patrol dangerous waters. U.S. Littoral Combat Ships use speed, aviation, missiles, and modular systems to fight near shore. Submarine rescue technology protects the sailors operating in the most unforgiving environment of all. Naval power is not only about attacking first, it is also about surviving, rescuing, adapting, and staying ready when the sea turns against the crew. That is the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.